Hello and welcome back to our continuing adventures on the CyberDefenders platform. Today we are going to tackle the deep dive exercise, or as it kind of looks, Emotet, exclamation point. So we are given a memory file in which we're supposed to use Volatility 2 to go through and procure answers for. So, let's see. Challenge details. We'll go through that scenario. You were given a memory image for a compromised machine. Analyze the image and figure out the attack details. And tools, volatility tool, 2, and then, I don't know, something else in regards to the resources. Oh, okay. Inside of the compressed image file, we are given just the memory file itself. Switch this over to questions so we can start running through. What profile should you use for this memory sample? So, and let me get the Remnox window up front. So what we end up having to do is we extract out the vmem file and we navigate to that directory, and we are running vol.py, so vol.py space -f to specify the input file. In this case, it's banking-malware.vmem, and then we're running a image info, and it will give us the suggested profiles as everything runs through. Now, unfortunately, we are given several. So Win7 SP1 x64, Win7 SP0 x64, Win 2008 R2 SP0 and so on and so on and so on. And that's basically denoted here. So we run the image info command, and then the suggested profiles breaks down inside of there, and I have copied it off to a Word document. Well, okay, not really a Word document, but a text document inside of this to go through. And then we're going to issue the commands. We're going to remove the image info. We're going to do -- profile equals, and we're just going to start with the first one listed, so Win7 SP1 x64, and then we're going to run a command. In this case, we're going to do ps list. You could run any command, and effectively, we're just going to go through and see what gives us results. And this, unfortunately, will probably take a little bit of time to go through and get done. Okay, so I mean, we've got some stuff that returns back there. So is there anything like right off the bat that we can just basically say, yes, does not work? We'll see if anything outright fails. In 2008, R2 SP0 x64. Wait, why are we not entering in? Inputs there, so what's going on, guy? Oh, read only, Okay. Yep, we still have stuff. That's basically just being reported back out. Memory addresses, everything else like that looks like it kind of matches. Okay, so let's approach this from a different end then. So it looks like we could effectively go through and just use about any of the Windows 7 portions without an issue. Okay, we got the suggestions. What if we do... what is it? KDBG scan and see if we can get a separate set of information off of it. I mean, because we've got a whole list of things that we can run through here. I highly doubt it's Windows 2008. But if we go through and let it do its scan, maybe it will give us a specific one. Wasn't there something else too in regards to an address that we needed as the second question? What is the KDBG virtual address of the memory sample? And just from the image info, which I think was consistent all the way through the two times that I did run it. So 0x8 or 0xF8000 to BEF120. So let's try and see where that gets us. So we got it copied and pasted. Looks like, okay, it looks like it starts the same way. Okay, so at least that's on the ball. And the scan is still running and doing its thing. Okay, so we're looking for the profile. Interesting, from the suggestion, it should be God, we're getting tons of stuff here. Let me bring that back up front. So I mean, we were being told Win7SP1 underscore X64 Win 2008 R2. Okay, well then in this case we're going to go through and take it, or use the test to take a test. So it's not really narrowing any of this crap down in the slightest. Because we're getting everything back. So it is specifically spelling out, so obviously Windows, and it's definitely going to be one of the ones that are underscored. But let's see, so it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters long before the underscore. Okay, so it should be an underscored item. So that's going to give us these. as a piece of info for this. And then we've also got the 2 items for Windows 7. And then I said we're looking for what, 10 characters? 2, 3, 4, 5, 6, 7, 10 before the underscore. So 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so it's got to be Win 7. Out of those 2 available portions. So we will do kind of the slightly brute force method. No. Okay, well then that changes it to 2400. Okay. Take the test, use the test, take the test. I mean, because we were still getting results, and unfortunately, yeah, I mean, it just comes back with all of those. So we could probably go through and do all of them. So from here on in, we're just going to specifically limit it to Win7 SP1 X64 underscore 2400. Okay. So when we move on to that, there's a malicious process running, but it's hidden. So what is its name? Well, we've got a pretty good build out. So let's put in the appropriate 2400. Okay. And from here on in, that's our base. Oh, yeah, it's going to be hidden. And we should be looking for something with a underscore in the portion. So what is that? PSX view. Because it should call out items that don't show up in like the PS tree and then the PS list and everything else. Being mindful that we are indeed looking for some sort of process that's running that has a underscore in the middle of it. Yeah, so PS scan and PS list do not list. VDS underscore PS.exe. Underneath PID 2448. So let's go back and let's see as to whether or not if this matches up with what we're expecting. VDS underscore, okay, yeah. And then we are looking for the physical offset of the malicious process. So that should be to the direct left from our PSX view. So 0x, multiple zeros, 7 delta 336950. So we'll copy. We'll move remnux out of the way. We will plop in the memory offset. Okay. And now we need to obtain the full path of this portion. Okay, so we need the full. We should be able to. What? VAD info. Okay, so take this. We go VAD info for the output, and we're going to use the memory offset that we just copied. And we'll see what comes out of that. Windows. Yeah, metric button, if you will, of DLLs. Why don't we just grep for exe? It's Linux. I think I've spent a little bit too much time in Windows land. Okay. What? Okay. That looks a lot better, actually. So instead of multiple lines, so we have file object. Points back to /device/hard disk volume 1/users John. So it looks like the typical breakdown of C:. As the question itself. Oh, crap. I don't have I'm not showing. Okay, we're looking for C:. So effectively just did VAD info space -o space, and then the memory address we pulled from the PSX view. And unfortunately, I didn't think to sit there and use grep, so I was working my way through all of this. I'm sure I probably could have found it, but it just would have taken a while. So our location then is going to be C:/users John app data local API-ms-win-service-management-l2-1-0/vds_ps.exe. Oh, cripe. So, of course, the next aspect is what malware is this? And so far, everything that I've observed, I have not seen much of anything like this before, but I don't suppose we could just take the file name and just do some OSINT quick. Oh, Joe Sandbox reports Emotet, which of course is kind of also given away by the fact that okay, it's not the title. The title's DeepDive, but the image that they splash on the top of that portion is Emotet with an exclamation point. But so, yeah, right here. And then, of course, denoted Emotet throughout this whole thing. Although we don't quite see the same breakout, but it is using the same file name. Okay, well, I mean, it's not that big of a shock, realistically. But, okay, so let's say we didn't think to do OSINT. How would we effectively get this without just OSINT? Say we don't, well, okay, even if we did it, if we could say no working internet connection, I mean, we're still kind of hand tying ourselves, but, what if we didn't know the exercise's title aspect was Emotep with an exclamation point, and what if for whatever reason this is going on at the time? So, we are going to use something else. We're going to do dump files. Dump dir equals dot, and it's Q for the actual address. Maybe? Let's see if I screwed that up. I think I screwed that up. Oops. This is not a directory. Oh, trust me, I'm well aware. I'm trying to remember what was it before to just pop it in. Okay, fine. Let's make a folder. We're just gonna call it dump. I know. Imaginative, isn't it? And let's just specify then the folder called dump. Go inside. Yeah, so it's empty. All right. What am I doing wrong with my notes here? Dump. Really? Is it because I'm using it wrong? So it should be dump slash. Oh, I'm going to be upset if that's the case. Nothing there. Nothing there. Okay, fine. Print working directory. Let's do this. Slash home slash remnox slash downloads slash C60-banking slash dump. We have put it in the absolute path. Come on, dump. And even with the absolute path, nothing. Oi. Let me pause this and I'll go back through. Okay, different way to skin a cat. Switch from dump files to proc dump in order to sit there and pull it down since we have the memory address, and that gives us, so just basically removing dump files space -n and replacing it with proc dump. The --dump--dir directory remains the same, and then I swapped out the -Q for --offset equals and brought everything in. So now we have that. So theoretically what we could do is we could go and we could generate a hash, and we could dump it into VirusTotal or Sandbox of choice, whatever you've got access to in order to sit there and look the stuff up. I think we're just going to go straight to taking the executable and uploading it to VirusTotal. Now, mind you, depending on the circumstances as you're going through this, you may not be able to. You might have to sit there, jot down the hash, and actually take it to a separate workstation without internet connectivity to go through and do this. Really? Apparently I got a little bit too happy with the enter key. All right, so just move that over, and we'll let that do its own computation of the hash. So we get something from 28 days ago, effect demo.exe, but pretty well spells out emotet. Emotet. Oh, there's one that would throw you. Trickbot. Trickbot, emotet, emotet, trickbot, emotet. All right, so that would basically get us at least halfway to the finish line as this stuff sits. But for example, so we could go through and do a cd dump, and we could do, say, md5 sum executable, and so it gives us starting in 30 Bravo Delta, ending in Bravo 606. And then we can confirm here by going to details. So 30 Bravo Delta, Bravo 606. So we could literally just take that, dump it down. If you've never used VirusTotal before, we could enter it into the search bar, hit it. I mean, this is literally just going to take us right back because it's all done by the SHA-256 hash. Notice here, confirmed here, but then just shows up here. A quick and dirty for VirusTotal. Okay, so that gives us, well, we're down to the last couple of sets of questions there. So we've confirmed emotet through a couple of different means, actually just utilizing and dumping the process, getting a hash and running through, or just go and trying to sit there and Google search the name of the executable. So obviously, if it would be something like explorer.exe, you're going to kind of have a harder time with that one. Okay, so it takes us to 7. The malicious process had 2 PEs, portable executables, injected into its memory. What is the byte size in bytes of the VAD that contains the largest injected PE? Answer in hex, like 0xabc. DEF. Okay. So let's go. Okay. Remnox. Oh, crap. You need to go back one directory. Okay, here we go. So, let's try malfind. See if we can't finish this up in short order. We're already 30 minutes past. Process SVC host. Explorer. Yes, this could take a little while. It would have been WMP network, STX helper, STX helper, STX helper, compatibility. I have question. We have the offset value already. Will this help? Rather than giving us all of that? Okay, yes, that does help. Looking at the output. So that gives us the process, the VDS underscore PS. And so it is giving us addresses. Now the question will be, is there 3 of them? Go down one, okay, yes. Yes. So that's 2 so far. And there's 3. They all were denoting for the same PID, right? Yes. Okay, so we've got 3 addresses. But should be 2 injects. I mean, which one's the bigger? I mean, value-wise, it's going to be 0x2a80000. It's the largest offset out of the three that we've actually had for address portions. So let's see if we're in the ballpark. So 0x2 alpha 80000. No. Size in bytes of the VAD that contains the largest injected. So we're gonna have to do. Okay, well, I mean, we've got the addresses. So if we skip malfind, because we're effectively done with that, we got those portions. So VAD info to answer the question. We have our offset for this, and then we have our, we'll go with our addresses. So 0x, let me guess, I did not put that back in. No, I did not. Remnox, back up. And then so we're doing 220000. And then it is 0x2 A1 1 2 3 4. And then we have 0x2A 80000. But it's not giving us anything. We've got the VAD node, VAD node, VAD node. We got the start and stop addresses. We can't use. Crap, we're gonna have to do Hex Math, aren't we? I'm gonna have to take the end because it's bigger and subtract it from the start. I think. Cripe. Let me see if I'm even remotely in the ballpark. So I need that address. cripe. So I need to do Hex Calc. I don't think I can do that in CyberChef. All right, so I need we're taking out the zeros. So if we take 2 alpha bravo 6 FFF and we minus 2 alpha 8 0 0 0 0 according to calculator.net, all right. So that gives us a value of 36 FFF, or in decimal 225279. So let me run the calc on the other aspect. So this one's done. So we take the bigger of the two. So in this case, 2 alpha 2 Charlie FFF. And we're going to remove 2 alpha 1 0 0 0 0. That's definitely a smaller value. Which is not a huge shock. And then just for sake of completion, because I just want to make sure, even though at this particular point I don't see as to how it would be even remotely feasible, because we're kind of working this backwards, but just in case. Okay, so there's our values. And it should be 5 items. So it could be any of those hex values. 1 FFFF, 1 Charlie FFF, or 36 FFF. But given the fact that the biggest is 36 FFF, we're going to run with that one. So 0x 36 FFF. Okay. Oh, crap. Okay. So, last 3 questions. We are getting there. Dadgummit. Okay. So, this process was unlinked from the active processes list. Follow its forward link. Which process does it lead to? Answer with the name and extension. Well, we already know it's .exe, so that doesn't seem to really do a whole hell of a lot for us. But I think this is going to be a PSX view. We're going to kind of go back the same way that we were. So let's just go ahead and rerun it. And yes, I realize I do not have Remnox up in front. It is now. So we're just going to go ahead and pull this up full screen. Oh, I realize I have part of that screen cut off for some reason. I might have dragged it a little bit too far over. I think I did. Here, let me transition that over. That's better. Let me get that locked into place. Okay, so there's our malware, so it's something that should be unlinked. It is PS tree, right? I vaguely recall. Hmm. Hmm. I hmm. Okay, it should be safe to have that back up, right? Yes, that does not cut off the window. Okay. So what is it? It's like the next PID in sequence. So we're looking for something that would be next in line for 2448. I mean, we got 2616. That's too high, that's too low. Those are all too high or too low. 2416, wrong direction. 2024, wrong direction. So we're looking for something closer to 2448 that is not 2616. 2688, wrong direction. That's now outside of that portion. Maybe? So it would be search indexer? Does that... Oh, let's use the test to take the test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13 characters? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that looks like that would match. Okay, Well, yeah, it would be unlinked because that thing doesn't show up in the PSX list or tree. Because realistically, that would be like the parent process. That would be the sub process, wouldn't it? I don't know. I think. Okay, so last two. What is the pool tag of the malicious process in ASCII? Use full shell. I did. Wasn't it? I had to use full shell in the last exercise. I did. So let's see. Full shell, and then we're looking for pool tag. We have. Excuse me. We have the space dump. Where'd it go? There it is. Okay, yeah. All right, so we take the address and space equals ADDR space. So I just ran vol shell and I'm sitting there looking for, I don't see pool tag. Yeah, I think we need, because it's the process itself. So let's move backwards. understanding the reference document correctly. Hmm. Yeah, I don't know. Okay, I am not gonna lie, I had to ask for help because I have no idea what I'm doing here. So basically, they gave me is in the right ballpark in terms of the command from just looking at the full shell reference. But apparently, instead of eProcess, I'm looking for underscore pool underscore header, and I need to take the spaces out between the offset to in which that we know for that VDS underscore ps.exe, and we have to remove 60 from it in order to walk it back. Something about file header, but we're given a value finally. It changed how everything looks, so we have a pool tag with a value of 14165731010. So we have our pool tag. Hooray. Now what the hell do we do with it? It's supposed to be four characters according. What is the pool tag of the malicious process in ASCII? So we need to take that and convert it to ASCII, I think. Now, suppose there's a ASCII in CyberChef. So maybe I can take that and do something with it. It should come out to 4, huh? Okay, So if we take the decimal value, and we're going back to that calculator.net. So if we take that and we change that to hex, then that becomes that. And is there a hex to ASCII calculator? Of course, I could probably just ask as to whether or not if there was just a hex to ASCII string table or string converter. Hexadecimal to text. Okay, that's something. Can we go from and apparently it becomes tor to or if I'm doing this right. Okay, how about a decimal to text? So could I just take that number according to this and have it pop out in ASCII? No, because then it comes out as question mark, WO, question mark, and that's one more character more than what we actually have. Bear with me. Okay, let's try. It's our 3 characters. So it is supposedly capital T, O, no. Okay, what about reverse? No? Wait. The O looks different. What if it's a... Interesting. Root. Hmm. am at a complete loss. But screw it. I might have to sit there and see about trying to investigate how in the hell that plays out, because it should be the inverse. It should be T little o, so capital T little o, 0 capital R, according to that. Okay, apparently it has something to do with the Indian value was wrong, and not INDIAN, but ENDIAN, which explains as to why is the way that it is in regards to that. Okay. So taking the number from the pool tab, so 1416573 converts to 546F3052. But if we dig down, again using the rapid tables portion, so we get the 2 portion for Little Indian, Big Indian. So the 546F3052 converted becomes that TOR, so TO0R. Whereas if we switch to Little Indian, so converting the 546F3052 becomes 52306F54. So we switch this over to hexadecimal to text. And so if we take our initial and convert, we get the TOR. We take the other Indian value, so 5230, and there's root. And of course the ads, because I don't have uBlock Origin installed on the Remnox web browser. Okay, so that explains as to how we got to that particular aspect. That we'd have to take and work down to both Indian values concurrently and see as to what would shake out there. I have no idea as to how to make that assertion from what we had, but in terms of how we came to root rather than TOR comes down to the Indian value that was there. Then our last crap. Just realized I still had the Firefox portion up that I had, the separate one, not the one inside of Remnox. So effectively, okay. So here's what it ended up being due to the Indian value. So root. And then if we just take the straight hex conversion for the decimal that we were given, there's TOR. Okay, and so then the final portion is they want the address in regards to the pool tag, which gave us the 14165731010. So we get the pool header. We have 0x7 delta 3368 Foxtrot 0. Except that is not going to be our answer. That is the base. But notice the pool tag is at 0x4. So just to show. No. But we add the plus 0x4, which changes the 0 to a 4. There we go. Wasted a good deal of time sitting there just kind of staring at the numbers previously. I'm like, they give us the address, then they give us the value on the left. So it's like it would be way too easy just to sit there and put where the actual header value is. So it's all these other sections have to correspond to a different address as opposed to anything else. So it makes sense that since pool tag is all by itself at 0x4, that's where it's going to sit. I'm going to mark it high marks. Mark it is difficult because of the use of vol shell. And I will get this stuff processed out. I will include, as normal, the command reference and have it specific set to vol shell, although, I mean, it's just the Volatility Foundation's wiki command reference on the GitHub page. But I will have it specifically targeted down to this particular aspect. And I will include the info mask in the object header. But yeah, I needed help on this. This was not something I was going to sit there and just kind of pull out of my butt in regards to those last couple of aspects. So thankfully I know a few people that had gone through and done this already, so I was able to sit there and ask them. But yeah, that's down the rabbit hole. That's a little bit too far for me as it sits. But and I could not tell you what the significance of that pool tag would end up being. I don't know if that's what the user account this thing is running under. So there was a root account that was basically just reset or basically created on this Windows 7 host, or what the case is. But I'll get all that stuff put together, get this stuff out, and I may just make my 5 o'clock window because I'm doing this on the day of the 31st. So tomorrow is New Year's. So if you've stuck with me this far, everything else like that, thanks. And assuming you're not somewhere in the world that's already crossed over, Happy New Year, as it were, is somebody who has still several hours before in his geographic physical location actually reaches that particular point in time due to time zones. But so hopefully your 2023 is a good year. But with all that being said, I will see everyone in the next video.